Hi, we are from Applied Science and this is our member for this group assignment. What is the definition of differentiation? Basically, differentiation is a method of finding the derivative of a function. This is the techniques of differentiation.
Hi, I am RUBIANA. Let's take a look at question 1a. I want to find the derivative dy over dx for the following function, which is y equals to in bracket 4x plus 10 raised to the power of 5 multiplied by ln in bracket 4x plus 1. Let the first term be fx equals to in bracket 4x plus 10 power of 5. We apply the power rule combined with the chain rule here. Bring the power of 5 to the front, subtract 1 from the exponent to get a power of 4, and then multiplied by the derivative of the inside function, which is 4. So the f prime will be 20 in brackets 4x plus 10 raised to the power of 4. Now, let's find the derivative of the ln in brackets 4x plus 1. The derivative of the inside expression is 4. Using our derivative rule for logs, that puts the 4 in the numerator over the original inside function. So, our g prime x is 4 over 4x plus 1. Now, let's assemble everything using the product rule formula, which is fx multiplied by g prime x plus gx multiplied by f prime x. Substituting our pieces into the formula, we take the original first function, 4x plus 10 raised to the power of 5, times the derivative of the second, 4 over 4x plus 1, plus the original second function, ln in bracket 4x plus 1, times the derivative of the first, which is 20 in brackets 4x plus 10 raised to the power of 4. Finally, let's group the terms to clean up the expression. Our final derivative is 4 in brackets 4x plus 10 raised to the power of 5 over 4x plus 1 plus in brackets 20 in brackets 4x plus 10 raised to the power of 4 multiplied ln in brackets 4x plus 1.
Hi, my name is KHAYRA. So now I'm going to explain question 1b. So this is the question. So first, we have to differentiate the numerator and the denominator. And then we plug in into the quotient rule formula. After that, we will sub into the formula. Now we will expand the function. And then we can cancel out and simplify it. And we will get our final answer.
My name is AMMAR. Okay, now we will solve the second question. We would like to find the dy dx for 10x power of 3 minus 4x in bracket y squared equal to 1 over exponent power of y plus 5 ln bracket x 3x minus 1 by implicit differentiation. Firstly, we need to differentiate each term by adding d over dx in front of each terms. Next, we will separating all the terms. For the first term, we need to apply the power rule and we will get 30x squared. For the second term, we need to apply the product rule and the chain rule. And we will get negative 4 in bracket y squared minus 4xy cos bracket y square dy over dx. For this term, we need to rewrite it as exponent power of negative y and apply the chain rule. In term 4, we need to apply the chain rule for the logarithms. Now, we will combine all the terms. The second step, we need to rearrange the dy over dx on left hand side, meanwhile the others on right hand side. For step 3, we need to do the factorization. This means factor out the common dy over dx term on the left hand side. Finally, divide both sides by the bracket term to solve for the final derivative.
Hi, my name is AQILAH. Today I'm going to explain question 3. First, we define the function from the equation. We want to estimate the value when 80.44 using linear approximation. Since 80.44 is very close to 81, we choose because it's easier to calculate. Now, we differentiate the function. And we differentiate terms by terms. Now, we find f bracket 81. So, we substitute the 81. So, we got the answer after we differentiate. Now, use the linear approximation formula. And calculate using calculator. Therefore, the estimate value correct to 3 decimal places is 3.218. Thank you.
In conclusion, differentiation is a fundamental concept used to determine the rate at which a function changes. This tells us the slope of our curve at any point, and we are able to find the derivative of any function. Thank you, that's all from us.